The next subject that we're going to cover is actually going to expand on chemical reactions. Talk more about acid-base reactions. There's a wider definition of acid bases that we want to cover. If you're going to take 111, you will definitely be seeing acids and bases. So this is good place. So actually, they will be asking you. You'll get a review of this in Chem 111. But so let's get you ahead a little bit so that you can know what to expect from them. If you're going to take 121, you won't be covering acids and bases, but if you're taking 122, you will. Okay, so let's take a look. So acid bases. We saw in a double replacement reaction, we had something called an acid-base neutralization reaction, and it was of the form of your acid, which we wrote as H plus and then X minus, whatever that, like HCl minus, and then your base was always a metal and a hydroxide. There should be a minus here. And then you have your, if what happens is the H plus combines with the OH and the metal and the non-metal combine. And so you end up with a new ionic compound. We call it a salt. Okay. Just another name for ionic compounds are salts. And then you've always formed water. Okay, base is an ionic compound with a hydroxide. Let's go back and look at some of the things we've learned about acids. First of all, an acid will always have a H plus H in front. Okay, and then the name acid. We saw an acid-base reaction that the H came off as H plus. All right. And in a sense, the OH minus and the H plus come together to form HOH. So kinds of different ways you can look at this is that maybe one way to think about it is the OH comes and grabs a hold of the H plus and makes water. So the acid gives off an H plus and the OH takes it. Okay. Now these types of reactions will always take place in water. So what we're going to do is expand on this and get a more general definition of an acid and base. So far, our definition of an acid could be just that it's a substance that gives off an H plus when in water. And our definition here of an acid is a hydroxide. Okay, all right. So ionic compound with oxide. But let's actually take a look at the property of the hydroxide and what's happening. Okay, so let's study what is H plus and how it relates to the reaction. So hydrogen is atom has one proton and one electron. We can learn that from the periodic table. Has a atomic number 1, and usually the number of protons is an equal number of electrons unless it's an ion. So in this reaction, what happens is you have your acid HX that will combine with your base. Okay, so let's look what happens here. So actually, what happens is the X kind of takes away that electron there, and it releases the H plus. Okay, then this guy, ionic compounds, when you put in water, they split apart. Okay, and then what happens is these guys come together to form water, and these guys come together to form the salt. So we can see that the hydrogen acid, okay, donates or gives off an H plus. So this H goes off as the H plus, or gives off or donates itself in a sense of a proton. So another name for a proton, because after the H comes off, all it is a proton, because the electron has stayed with this minus here. Okay, so another name for a proton is a hydrogen without electron, or H plus. So whenever you see H plus, it's simply a proton. And then we can only do that when we talk about acids and bases. If you ever see a proton If we talk about protons in any other types of situations, we don't talk about them as being H pluses, only in acid-base reactions. And so, actually, what we got now is a new definition of acid and base. An acid produces H plus in water. Okay, so we just saw that the acid gives off H plus in water, and in our case here, as we said, a base gives off OH minus in water, and they form water. Okay. So so that's simple, and so here we have our definition of acid and base as it pertains to our double replacement reactions. Okay, and these just show you the reactions that take place. You don't have to worry about these down here. Okay, it's just a way of explaining what I just told you. You have to just know this up here. Okay, now there's a more general definition of a acid and bases that reflects how the base actually works. So an acid is, again, basically something, a molecule that gives off a proton, or H plus, in water. Now, a base is the guy that grabs a hold of the H plus. So in our previous example, the OH minus was the proton grabber, so it's technically the base. Okay, so let's look at a chemical reaction and see if we can figure out what's. Look at this definition here. You have to know this definition, by the way. And Arrhenius, the previous definition, which is called the Arrhenius definition. So let's look at this and use to figure out the Bronsted-Lowry definition of an acid and base. So I'm going to get HCl plus H2O gives me H3 plus O plus Cl minus. So the key is to look at these two guys here and to see which one gives off an H, okay, or which one receives an H. So there are different kind of way you kind of look at it. But if just take a look at this guy. So this guy goes from HCl to Cl. That means it's giving off an H. So it's the acid. And you could have known that anyways if you remember your formulas. This is hydrochloric acid, so that makes sense. And now notice that the H2O becomes H3O. So you've gone from 2 H's to 3 H's. And so it's gained that H plus, and so it's the base. So when you look for Arrhenius acid, you look for a substance that gives off an H. And when you look for the base, you look for a substance that absorbs the H, or gains an H. And it's the H plus technically, not just H. All right, so let's look at another example. We have something called formic acid, which is this right here. And let's combine it with water. All right. So when it combines with water, what happens is this H comes off. Okay. So this guy becomes this over here, and the water gains the H. Okay. So this becomes the acid. So this is the acid, and this is the base. Okay. Now, if you notice, okay, this double arrow here, and what we're going to talk about a little bit more specific in a minute, is that the reaction can actually go back in the other direction. Now, up to this point, every single chemical reaction that we saw always went to left to right. But it turns out that every chemical reaction could go both ways, but it tends to only go one way. So we kind of ignore it in this class. Except for acids and base. So since this reaction can go back, and we're going to go explain why it can do that in a minute, this reaction can also go back this way. So now if you look at the reaction going the other way, you'll see that now looking at these two guys, you can see that the H3O plus loses an H, so it becomes the acid going this way. because it loses the H, and this guy is the base going this way. All right. Okay, so what you can see is the acid turns into a base, and the base turns into an acid. Okay. And these are called conjugate pairs. So if you have the double arrow, and that means the reaction could go back and forth, the acid will always turn into a conjugate base, and the base will turn into a conjugate acid. Okay, so let's explore this double arrow thing. So let's look at this reaction here and this reaction here. And if you look at it, the big difference between the two, besides the chemicals, is the arrows. All right. The top one has it only going one way, and the bottom one has it go both ways. So what is this? Okay, so this means, I told you that the reaction could go back and forth. That means we say it's reversible. While this reaction, with this arrow going only one way, that means the reaction is irreversible, and it can only go one direction, to the right. And the reason for this is that this reaction here, this acid is what we considered a strong acid. And I'll be talking about that in the next slide. So in this reaction up here, since the arrow only goes to the right, it doesn't form, it can't go back to the left. Therefore, there's no conjugate acid or conjugate base. Okay, but now if we look at the bottom one, it has a double arrow, so that tells you the acid is weak. Okay, so this is a weak acid. All right, and this is the acid right here, because if you notice, it loses an H, goes from here to here, and this is my base. Okay. Well, going back the other way, since this was acid over here, that means this must be the base on this side. So this must grab a hold of an H over here and the base. Okay. So this is the acid, and this is its conjugate base. This is the base, and this is its conjugate acid. All right, so what is the definition of a strong acid? A strong acid is an acid that completely splits up into H plus and X minus. So it doesn't reform. It doesn't reform the HCl or whatever. Okay. So the way you can tell, so the definition of a strong acid is it doesn't reform the original acid. And the way you can identify if it's a strong acid or base in a strong acid in a chemical reaction is to look at the arrow. If the arrow is pointing one way, then it is a strong acid. So let's do a little bit more with the conjugate acid and bases. Okay, so here's your acid and base. And by the way, on a test, I'd give you the complete reaction, and all I would ask you, what is the acid, the base, conjugate acid, and conjugate base? So let's take a look at this example here. You see HCO3 minus, okay, and you notice this guy turns into this right here. So this is the acid. Okay, that means that this guy is the base. All right, and we'll talk a little more about that in a second. Now this OH minus grabbed a hold of this H right here to form water, so it's the base. Now, this is a weak acid. You can tell by this double arrow. So that reaction must go back this way. Now, if you look at it going right to left, you can see that now this guy here loses the H. Okay, one of the H's comes off, combines with this to form this. So, going back the other way, okay, the base turns into an acid. So these are a conjugate pair. And these are what we call a conjugate pair. Okay, on the bottom, you can see that these two are the same substance, okay? But up here, this is the acid. Now you can see it's going to behave like a base, okay? And there's a reason why that is, okay? But right now we're just going to write it. You can see that this guy here actually gains an H, goes from HCO3 to H2CO3. So it gained an H, so it's a base. And this guy lost an H, so it's acid. It's a weak acid, so the reaction could go back the other way. And so you have your conjugate acid and conjugate base. Right, so let's take a look at these and 3 examples and find out what the conjugate acid and base is. So if you look at this guy up here, you can see that this substance here loses an H. It becomes this, so this is the acid. You see that this guy gains an H, so it's the base. Okay, it's a double arrow, so that means this is a weak acid. Okay, that means it can have a conjugate acid and conjugate base. So this becomes, so this is the base on this side, now it's the acid on this side. And this acid becomes the base on this side. Right, take a look at this reaction here. So which one's the acid? You can see this should be a minus sign here. That this guy loses an H. Okay, turns into this, and the OH grabs that H and becomes water. So now this is the acid. This is the base. Double arrow tells you that it's a weak acid. That means the reaction go back the other way. So now this is the acid going the other way, and it's the base. And this guy going in the other way is the acid. And then this reaction down here, the HCl goes to Cl, loses an H, so it's the acid. The ammonia gains the H, so it's the base. But the arrow is only pointing one way. It's a strong acid, therefore there's no conjugates. All right, we saw in a couple slides ago that HCO3 minus acted both like an acid and a base. These things are called, when it can do that, it's called an amphoteric. That means it can be either acid or base. Okay, and many substances can be like that. Okay, so water is amphoteric. And here's an example of it. So in this case, water is a base. It grabs a hold of the H here, and it forms H3O+. And here, it's an acid because it loses its H. This guy grabs a hold of the H and forms ammonia. So water is amphoteric as well. So let's look at the special implications of that. So let's take a look at it in terms of what happens. So actually, if you have water and water, what happens is some water, maybe like we'll call this water A or water 1 or something, water 1, and this is water 2. And what happens is if water 1 can act like an acid and water 2 can act like a base. And so now this is water 2, now it's gained an H, and this is water 1, it's lost an H, okay? So, and the water is a weak acid. We can tell by the fact it's double arrow. Sometimes we can just write the equation as 1 water splitting into H plus and O minus, and this is actually the way we'll consider it, okay? All right. So, so this is called the self-ionization of water. It splits apart. It doesn't happen. It doesn't look like it happens very much. It only happens about 1 out of 10 million waters. Okay, that doesn't seem like a very big number, all right? 1 out of 10 million. Okay, so now let's say, 1 out of 10 million doesn't sound like a lot. So let's say that some odd event happens, like 1 out of 10 million people, an arm flies off. Just it randomly flies off. 1 out of 10 million people. Well, the total population of Ohio is about 10 million. So, so only one person in Ohio is ever gonna, the arm's gonna fly off. So I'm not gonna walk around worrying about that happening to me, because that's not gonna happen a lot. Okay, but now if we look at the total population of the Earth, which is about 10 billion, okay, this is going to happen 1,000 times. So you're going to start to hear on the news of this happening a whole lot more times, and you may start to get worried about it. Now, if the population of Earth was 1 trillion, thank God, hopefully it won't get there, because that'll just be horrible. This event would happen 1 million times, which sounds a little bit scary, okay? Okay, even though the odds stay the same, it happens more often, okay? So the more you have, the more the event happens, okay? So in a cup of water, where there's about 1 trillion water molecules, and we'll talk about this in the next material we cover, this would, and the water splits apart every 10 billion, you would have 100 trillion waters that split apart, okay? So that's a lot. So we actually, even though the number of water split apart only 1 out of 10 million, because there's so much water, it actually happens a lot, and we have to take this into account. Okay, so what we want to look at is how much product a product is formed. So if we go back, the acid turned into a base, this guy over here, okay, lost its H, and this guy here became the acid. So we'll call this this the acid, and this the base. And then what we want to do is look at the ratio between the amount of acid and base. We can rewrite this if we only consider one water splitting apart. It splits into an acid part and a base part. Okay. Now, if you think about that, this guy is the H plus, and it will combine with this OH minus. We'll grab a hold of this. So this is the base, and this is H. So what we have is that we want to look at the ratio. I mean, we want to look at the amounts of both the acid and base, and we come up with this equation here, which is called the equilibrium constant for water, and you don't have to worry about that a lot. You won't have to memorize it, but that's what it means. And what we want to look at is the amount of acid and base that's formed in water. So when water is at normal room temperature, which is about 25 degrees C, which is about 70 degrees Fahrenheit, it turns out the amount of acid and the amount of base are equal to each other, okay? So which is the amount, so water just splits into one water splits into, out of 10 million, splits into acid and base. And then we could, so it's simply going to be these two values multiplied together from the previous page, and you get this. Now, if you don't know how to work exponents are kind of easy if you don't have to worry about a number in front. If it was like 2.3 times 10 to minus 7, that gets a little hairy. But if you just have 10 to the minus 7th times 10 to the minus 7th, when you multiply those two together, it's simply you add the exponents. So 10 to the minus 7th times 10 to the minus 7th is equal to 10 to the minus 14th. Okay. And what is 10 to the minus 7th? 10 to the minus 7th is 1 out of 10 million. And so what we're going to do is we're going to deal with negative exponents because they're easier to write out than 1 over. So this is pure water, okay? But pure water, we don't always have pure water, okay? And you don't always have an equal amount of acid and base. And what you can do is that you can increase this amount, all right? And that actually, if you increase the amount of acid, what happens? The amount of OH goes down. We'll show that in a minute. Maybe you could add hydrochloric acid, and so you get more H plus, or you could add more base and make more OH minus. So there's ways of disturbing the amounts over here. Okay, so it's not equal. But the curious thing is when you multiply the amounts, they will always equal this number here, 10 to the minus 14th. These at room temperature and normal pressures. So let's have some example where I'm actually able to change the H plus concentration. Okay. All right, and I change it to 10 to the minus 8th. And so what that means is now I have 1 out of so there's 8 zeros, okay? What is that? 100 million. So 1, 2, 3, 4, 5, 6, 7. Okay, 1 out of 100 million. Okay, and the way I would do that is I'd add some acid maybe, and then there's ways of know you could do. You can have a measurer that can tell you how much acid is. So let's say the H plus is 10 to the minus 8th. What I want to do is find out how much OH minus is, and also if this solution is acidic, basic, or neutral. Okay, so remember the product of the OH minus and H plus always have to be 10 to the minus 14th. So what we have here is 10 to the minus 8th, which is the H plus, times OH minus has to equal 10 to the minus 14th. Right, now if you're not familiar with exponents, as I just told you, simply the exponents added together will have to equal minus 14. So minus 8 plus what will make minus 14? Okay, it's minus 6. So the OH is minus 6, 10 to the minus 6. So OH minus is 10 to the minus 6. H plus is 10 to the minus 8th. So and if you look at 10 to the minus 6 times 10 to the minus 8th is 10 to the minus 14th. So which is bigger? What is bigger? 10 to the minus 6 or 10 to the minus 8th? Okay, so this is base or an acid. So which is bigger? More acid or more base? That's what we're going to look in the next slide. All right, so let's look at these two numbers, 10 to the minus 6 and 10 to the minus 8. So 10 to the minus 6 means 1 out of a million, okay? And 10 to the minus 8 means 1 out of 100 million. Okay, so which one's bigger? So obviously 1 out of a million is bigger than 1 out of 10 out of 100 million. So 10 to the minus 6 is bigger than 10 to the minus 8. So that means there's more acid, okay? Which is bigger? So which is bigger? All right, so obviously you can see that there's this is bigger than this, okay? All right, that means there's more base than acid, and so we say that this solution is basic. Now, if you have a hard time with figuring out not doing this 1/1,000,000, things like that, another way, quick way to think about it is -6. If you think about negative numbers, -6 is bigger than -8. So -6 is bigger than -8. So there's more of this than this. Right, that was example 1. Now example 2. Let's say the OH minus is 10 to the -9th. What is the H plus? And is this basic or acidic? So we know, here's our equation. Okay, we know OH minus 10 to the -9th. So what -9 plus what gives me -14 is -5. So H plus is 10 to the -5th. And what's bigger, -5 or -6? Well, -5 is bigger than -9. So there's more H plus than OH minus. This is 10 to the -5th. This is 10 to the -9th. So the solution is acidic. Okay, example number 3. Let's say the H plus is 10 to the -7th. What is the OH? And what's this, acidic or basic? Again, we have this. The product of two acids equal 10 to the -14th. What plus -7 gives me -14th? It's -7. So OH minus is also 10 to the -7th. Well, now, these two, this guy, the OH, the base, is equal to the acid. Okay, so we say that solution is neutral. All right, so what we have here, when we look at it, when the H plus, this can also be written as H plus instead of H3O plus, is equal to OH minus. It's neutral. If the H plus is greater than OH minus, it's acidic. And if it's the other way, the base is greater than the acid, it's basic. All right, now what we're going to do is come up with a new term. Now, writing down these exponents is kind of hairy when you write everything down, and usually when we measure the amount of acid, we measure in terms of 10 to the minus whatever. In scientists, we try to find shortcut ways to remember things. And what we have here is we have a shortcut way of writing down these exponents, and we use this thing called pH to do that. So pH, and you may have heard of pH before, and we'll get more into it in a minute, is a mathematical equation. It's minus log times how much acid you have. The minus log of how much acid you had. Now, if you have a calculator, it's pretty easy. You just, I don't know, that depends on the calculator. But like some calculators, they like if you put 10 to the -7th in, and then you hit log, what it's going to shoot back at you is -7. Other calculators do it the other way. You'll say log, you push a button that says log, and then you'll write 10 to the -7th. And then when you push enter, it'll give you -7th as well. We don't like negative numbers. It's just too much writing. So what we do is we multiply this whole thing by a negative, and so we get these things become positives. Okay, but we're going to make it easy for you, so you don't have to do this. Okay, now I don't know if you, depending on who you have, in Chem 111. If you have me, I'm gonna say have this technique. If you have somebody else, they might have you use the calculator. If you end up taking 122, you definitely are gonna have to use the calculator. But there's a real simple way of doing these without using this formula here to figure out pH. You simply take the exponent and the negative exponent of it. So 10 to the -8, the pH is simply 8. All right. For example 1. For example 2, where the H plus is 10 to the -5th, the pH is 5. For example, 3, where it's 10 to the minus 7th, the pH is 7. Now, for some weird reason, let's say you had a positive exponent, like if it's 3, then the pH is actually going to be minus 3. All right. Now, another weird thing about exponents is any number to exponent of 0 is equal to 1. Okay. So if you have an exponent of 0, that doesn't mean there's 0 of the substance. There's 1 of it. So we'll look at an example of this in a minute. Okay. And here's your 3 examples. But let's compare the pHs to what we found. We saw an example number 1, where the pH was 10 to the minus 8. pH is 8, simply negative exponent, and we saw that it was basic. Okay. For the second example, it was negative 5. So the pH of 5, and we found out that it was acidic. And then finally, on a third example, negative 7, pH is 7, and we found is neutral. Okay. So what we found is what you're going to see as if the pH okay, is equal to 7. It's neutral. Okay, so if the pH equals 8, that means the amount of H plus is equal to minus OH minus. Okay, if pH is less than 7, that means there's more acid. So, for example, if you have 10 to the minus 3 acid, it will be 10 to the minus 11th base. Okay, this would have a pH of 3. And you can see that this number is bigger than this number. And then if you have a pH greater than 7, it's basic. Okay, so on the tests that have to do with the acids and bases, I'll tell you what you need to know. But for acids and bases, you're not going to have to do. And this is actually the type of problem you'll have to do. I'll give you a table like this, and you're just going to have to figure it out. But first of all, you have to know that the formula, the product of what the acid product of the acid times the product of base is equal to 10 to the minus 14th. You also have to know the implications of that. And so it's that if you look at, find out the amount of compare the acid and base and determine if it's acidic and basic. So let's say I have a table here, and there's 4 examples: 1, 2, 3, and 4. And what I'm going to do is I'm going to give you one of the 3: this, the amount of acid, amount of base, and or the pH. And then what you have to do is fill in the other 3 columns. Okay, so I like to kind of think of this as acids and base. So in the first case, I give you this is 10 to the minus 4th acid. And then we have to tell me how much base it is, if it's acidic or base, and what is the pH. Okay, so to figure amount of OH, remember that the product of the H plus OH minus has to be 10 to the minus 14th. So it's going to be 10. So what minus 4 plus what gives me 10 to the minus 14th? 10 to the 10th. Minus 10th. Okay, which one of these 2 numbers is bigger? 10 to the minus 4th, 10 to the minus 10th. Well, minus 4 is bigger than minus 10. So that means that H plus is bigger than OH minus. There's more acid. So the acid is greater than the base. So it's acidic. All right. Okay, what is the pH? The pH is 4. All right. Next example. Okay, now I'm going to give you the amount of base. You have to figure out this guy, and this guy. All right. So first of all, figure out how much acid. So what times 10 to the minus first gives me 10 to the minus 14th, 10 to the minus 13th. Okay, which number is bigger? Well, 1 minus 1 is bigger than minus 13, so this is basic. And what's a pH? 13. Okay. So you can see so far that this one here, number 1, the pH was less than 4, and notice it's acidic. Okay. And the reason why it's acidic isn't because this is 4, it's because negative 4 is bigger than negative 10. Right. So on third example, I have 8 as pH. So what can I figure from that? I can figure out the H plus. So this is going to be 10 to the minus 8th. Okay, now I can figure out how much OH minus. 10 to the minus 6. Minus 8 plus minus 6 is 14. Minus 6 is bigger than minus 8. So this is basic. Okay. And again, you can see that the pH is greater than 7. It's basic. And the reason why is negative 6 is greater than negative 8. Not because the pH is 8. All right. Okay, the last example is I give you the amount of OH, 10 to the 0. Now, I told you that 10 to 0 is not 0. It's actually a number. It's the 1. But you just kind of forget about that right now. So what is the amount of H plus? Well, what plus 0 gives me negative 14? Okay, negative 14. What's bigger? 0 minus 14? 0 is bigger. So again, there's more base. What's the pH? 14. Okay. Now study this really. Go over this example, and now just quickly a little bit at the practical applications of pH. How do you measure it? So how can you figure amount of H plus and OH minus? Okay. We have something called pH. We measure pH, and if we know pH from the previous slide, if you know pH, you can figure out H plus. And if you can figure out H plus, you can figure out OH minus, and then you can find out which is greater, the H plus or OH minus. But a short way to do it is if your pH is greater than 7, it's basic, and if it's less than 7, it's acidic. There's different ways of measuring pH. One is we have a pH meter. You take a device, a glass tube, that's attached to some electricity, and it actually can measure the pH, and that's the best way of measuring it. Another way to do it is to use dyes, and you can use things like cabbage juice. Okay, and if you add cabbage juice to the acid, it'll change color, so it'll go from purple to green or yellow. And then another way to do it is something called litmus paper. Okay, you have red litmus paper. If it turns blue, it's basic. If it turns red, and we have a blue paper, and it turns red, it's acidic. So if you have red paper and you put it in the acid, it'll stay red. So acid, it'll stay red. But if you have base, it'll turn blue. Okay, for blue paper, if you have acid, it'll turn red. And if you have base, it'll stay blue. So the red and blue paper will give you the same result. Now all it basically does is tell if you have red acid versus base. Here's just a list of things that are acids and bases that you find in our normal day life. Okay, so it's one that you guys, if you take Chem 111, be concerned about is blood, which is about 7.3, I believe. And if that goes up or down, that can mess up your blood and it can mess up your whole body and possibly could die. And you'll learn more about that in Chem 111 and then more about that in nursing. Okay, so here's what you're going to, so this next test is going to be, a quiz is going to be a very short one. And here's the specifics which you're going to need to know. You're going to have to know definitions of Arrhenius and bronzoluric acid bases. And also definition of a strong and weak acid. If you're given a bronzoluric acid base reaction, and you'll be given the whole thing, you're given, you'll be given 4 parts, okay. Be given something yields something. Oh, you have to tell me what the acid base over on the reactant side. So which one gives off the H is the acid, which one takes the H, it's a base. And then is the acid strong or weak? And you can tell by if the arrow is, if it's just going to the right, then it's a strong acid. If it's going both ways, then it's a weak acid. Remember, that's a way of identifying if you have a strong or weak acid. It doesn't tell me the definition of a strong or weak acid. Okay, if the acid is weak, that means the arrow goes both ways. Tell me what the conjugate acid and conjugate bases are. So, for instance, this is the acid and this is the base. Then on the other side, the thing that turned into an acid is now the base. And the thing that the base turned into an acid. Okay. And remember, it can be acid plus base or base plus acid. Okay. And don't worry about the order here. Okay. And this A plus B could become so if it's conjugate acid, so that means the A turns into this guy and the B turns into this guy, or you could have A plus going to B plus A, and all I'm doing is showing you here. It doesn't matter the order, okay? So it's if it's acid plus base on the other side, well, whatever the base is, it's either first or second. Don't look for a particular order, all right? Just look what happens to the H's. Don't try to find some mystery way of writing this out, okay? It's what you have to do is pay attention to the H's. Then also I'm going to have a table like I just on the previous slide. And finally, I want you to be able to do this. So let's say I say the H plus is equal to 10 to the minus 8th or 9th. And the OH then is going to be 10 to the minus 5th. Okay. All right. And then I say the pH is equal to 9. And I ask you, is this this solution is basic, and how can you tell? All right, do not say because the pH is equal to 9 or less, greater than 7. And the reason why it's more basic, all right, it's more basic, I meant to say, is because 10 to the minus 5th is greater than 10 to the minus 9th. That means there's more OH than there is H plus. Okay. Now we can identify if an acid if its solution is acidic or basic by looking at its pH. It doesn't tell me the reason why. Right. Okay, so that's it for this this material here. And this is the last with chemical reactions, and we'll be moving on to the next material called stoichiometry.